Okay, so the diagram shows part of the curve of y equals this, 0.5 p53 lies on the curve, region A, etc., etc. Use the trapezium rule. Well, first off, I'm going to paste in the trapezium rule, and that comes straight from the formula sheet. So now I'm going to use it, and I've got two strips each. So I've got my x values. So I'm going to have two strips. So it'll be x0, x1, and x2. And that'll be 0 the first one, and halfway through will be 2.5. It says it's width 2.5, and the last one will be 5. My y value equals -3 plus 2 times root x plus 4. If I put in x as 0, then nothing plus 4 will be 4. Square root of 4, 2. 2 is 4. Minus 3 plus 4 is 1. And if x is 2.5, that will be -3 plus 2 times root 6.5, and put in root 5. 5 plus 4 is 9. Root 9 is 3. 2 3 is 6. Minus 3 plus 6 is 3. So I've got those bits. Now I can put it straight in here. The area doesn't equal, but it approximately equals a half times by the width, 2.5, curly brackets, times by the first plus the last. So I've got 1 plus 3 plus 2 lots of all the middle ones. I've only got one middle one. 2 lots of -3 plus 2 root 6.5. And if I do that in calculator, that equals 10.24754, which equals 10.2 to 3 significant figures. First part 2. Use your answer to part 1 to deduce an approximate value for the area of B. Well, that's the whole area of the whole rectangle. So B equals area of the rectangle, that's 3 times 5. Take away the 10.2. 15 take away 10.2. That's 4.8. And that gives me 2 marks. And part 3, by first writing in the form x equals some function of y, which I've got to do, use integration to show the exact value. So I first got to do this, and I'm going to do it up here. So first off, got to rearrange it. Since I've got to have it x equals, I'm going to put the x on the left hand side to start off with. So -3 not equals -3 plus 2 root x plus 4 equals y. Add 3 to both sides, so 2 root x plus 4 equals y plus 3. Divide that by 2, so root x plus 4 equals a half of y plus 3. Square both sides, so that will give us x plus 4 equals a quarter of y plus 3 squared, and take away 4, so that'll be a quarter of y plus 3 squared minus 4. So I put it in that form. What have I got to do? I've got to use integration to show the exact value of the region B is 14/3. So I've got to work out this bit. So I'm going to, I say that normally when you work out the area under the curve, so area under curve equals the integral of y dx. So the area to the side of curve equals, just switch it around, x dy. So I've got x, it's dy, so I'm going to have to basically integrate this. So I'm going to rearrange this a bit so I can integrate it. So a quarter of y plus, I'm squaring this, so y, I'll be y squared plus 6y plus 9 minus 4, which equals a quarter of y squared plus 1.5 y plus 9/4, take away 4, and that is a quarter of y squared plus 1.5 y plus 2.25 minus 4 is minus 1.75. So now I can get it, the exact area equals the integral of that, a quarter y squared plus 1.5 y minus 1 3/4 with respect to y, because we're doing this bit, and because it's dy, that means I've got to put the y limits in there, and we know that when x is 0, y is 1, so that's 1, so I've got to go between 1 and 3. And so therefore I've got to integrate that, and when I integrate it, the powers increase, so that'll be y cubed. If I differentiate, that'll be 3 comes down to front, I've got to be a quarter, so that'll be 1/12, and then plus that'll be y integrated, so increase, so it'll be y squared. So something times this bit by 2 to get 1.5, that'll be 3/4, and then minus obviously 1 3/4 y, and that's between 3 and 1, and that equals, chuck in 3, that'll be 27/12 plus 3/4 times by 9 minus 1 3/4 times by 3 minus, in brackets, put in 1, that's dead easy, that'll be a quarter, sorry, 12th rather, plus 3/4 minus 1 3/4. I can work this bit out. The first bit comes to 15/4, take away minus 11/12, and that equals 14/3, and that is exactly what they wanted it to be. So I know I'm right, and that's question 9 and the whole paper done.